Okay guys, I'm going to go through our next part of our measurement unit. So we've done one-dimensional measurement, haven't we? And that's just basically defining lengths and distances. So when we learned about length, we learned about how we can divide up certain lengths into units of length. So a unit of length might be a millimeter, a centimeter. So centimeter, millimeter, probably should have written this in order, meter, kilometer. And that was one dimensional. So that was the length of straight lines, things that were linear, or even not even straight lines. See, when we did the circumference of something, I know it's drawn in 2D, right? But it was a one-dimensional measurement. We weren't worrying about its width or thickness, just its overall length. So circumference kind of falls into our one-dimensional stuff. And then we did two-dimensional problems, and that was basically area. So we looked at square numbers, squares. We looked at rectangles, we looked at triangles, and we did the area of a circle. Okay, so one dimension we have length, or the distance between two things. Two-dimensional was area, and then three-dimensional, that's volume. That is asking how much space does this object take up? And so with our lengths and distances, we had our units of measurement, and same thing for our area. We defined a 1 unit squared was our measurement for area. So that was a 1 unit square. And then we asked how many of those unit squares went into each of our shapes. Okay, it's pretty similar for volume. So define 1 unit, and it's cubed now. 1 unit cubed. So that would be, pretty bad drawing, but that would be every side is the same length. So we define our, try to draw it a little better, 1 unit cubed. So we can define this as either a millimeter cubed, so a millimeter by millimeter by millimeter, or 1 centimeter cubed. And remember that 1 centimeter cubed was a mil and weighed 1 gram if it was made of water. So usually centimeter cubed is what we go for. So a little side note, actually, in a car, you'll notice on motorbikes or on cars, it is cc's. So 2000 cc. Well, that's 2000 cubic centimeters. Okay, so if a car is 2000 cubic centimeters, that is the volume there's the volume of displacement that all the cylinders take up in a car. And so that's why 2000 cubic centimeters is 2000 mils, which is 2 litres. So that's why some cars are 2 litres or 2.5 litres or 3 litres. Okay, so that's the volume inside that inside the cylinder of the car, and that's what the piston, that's the total displacement of the pistons. Anyway, what we want to get into is volume. So we define 1 unit cubed, and if we're figuring out volume, we're asking how many go into that shape, into that shape. So what I've got here is I've got 4 units along the bottom, 2 units wide, so 4 units wide, 4 meters wide, 2 meters deep, and we've got 1, 2, 3, 4, 5, 6, 7 units height. So depth and width. So I want to know how many 1 unit cubes go into this shape. So we can do this many ways. So let's just have a look at this first slice here. So let's just take this slice and how many cubes fit into just this slice here? Well, that is just 4 by 7. Okay, so it's 4 times 7, and then how many of those slices are there? Well, there's 2, so then we times that by 2. So we took 4 times 7 and times it by 2. So the volume is going to be 4 times 7, 28, times 2, and that's what? 56 unit cubes, or 56 units cubed like that. And so what did I do there? Well, I just actually calculated the area of one face, didn't I? Because it was 1 unit deep, so that's like taking the volume of this is just the area of the face times by 1 for that depth, and I calculated how many of those fit into the depth of the shape, and then so I multiplied it by how many deep. So we can do it another way. What if I got a blue pen and I calculated the volume of this top layer? Well, the volume of that top layer is 2 by 4. So 2 by 4. That's the area of the top, isn't it? And it's 1 unit deep. So that's and then how many of those layers? Well, there's 7 of those. So then I can times by 7. So I can have 8 times 7, which again is 56 units cubed. And then, unfortunately, I think I'm running out of colours, but I could have done it with finding out the volume of all of these ones down here. So volume for this one was 7 by 2, and that's just the area of this face, and then I've times by its depth back, times by 4. So that's 14 times 4, which is 56 again. And so this is actually an illustration. We've done this 3 different ways. This is actually a bit of an illustration that order does not matter with multiplication, does it? So the volume of a cuboid is base times height times depth, or width times height times depth. Okay, so just multiplying the 3 dimensions. But I did something a little different to just multiplying the 3 dimensions. I calculated a face area times by depth. So volume is face area times depth. You might want to get that down. And so let's have a look at what this might look like on a different shape. Let's have a look at, let's say we have a triangle. We're going to take a triangular prism. I'm going to say it's 15 centimeters long, and I'm going to say that it's 4 centimeters high and 5 centimeters wide. So what I could do is I could just take this front face, where it's 1 unit deep, and calculate this area. So what's the area? Well, it's a half times base times height. So that's 10 centimeters squared on the front. So I've calculated this base area, this face area. So the face area is 10 centimeters squared. And notice that area is just 2-dimensional. Now let's multiply this by the 3rd dimension, its depth. So volume is 10 times 15. So this area, and then I want 15 of those all lined up to give me my depth. And so that is 150 centimeters cubed. Interesting. So I could take any shape. Let's take this shape and let's go and give it a bit of depth. Okay, hopefully it looks okay. And if I just had the area of this thing, so the area is, let's say, 30 centimeters squared, and let's say that this was, I don't know, 4 centimeters wide, all I need to do is figure out the area to face and then multiply by its depth. So volume would be 30 by 4, 120 centimeters cubed. Okay, so we've gone all the way through, and we can say now that the volume of a prism, well, that's a face area times depth. And I think the easiest example is a circular prism, which we call a cylinder. Okay, we want the volume of this thing, and let's say it's 12 centimeters long, and its radius, let's say its radius is, I don't know, let's give it 5 centimeters. What we need to do is we'll go 1 centimeter deep, and then we want to times whatever this area is by 12. So volume is the area of the front circle, pi times r squared, times by depth. If you're in year 9, I don't care if you use 3 or if you use a calculator at home. I'll use a calculator today because this is also for some year 11s. So let's go shift pi times 5 squared times 12. We've just calculated the volume, 942 centimeters cubed, because all I did was get the face area and times by the height. With a cube, with a cuboid shape, obviously you've got 3 different faces and 3 different depths you could choose from. But this is obviously the only 2 faces on this are the two circular ends. Okay. So there you have it. There'll be some practice coming out with that. Hopefully that makes sense. Nice.